Okay. Then, after that, ni-proceed ta sa second law of motion. But we tried to check the effect of the mass and the effect of the force on the acceleration itself. Kaya ang acceleration man gud is magdepende man na siya sa imong force. So, di ba, naata diri si, I forgot na the name. So, si Barbara na lang ni, I don't know, I forgot the name. This one. So, gibira niya ang kaning table. So, gibira niya ang table within how many seconds? Within 4 seconds. Pero, granting that the same lang siya nga mass, the same table lang, pero this time, gitabangan na siya sa iyang boyfriend, for example. So, in this case, the force is now increased, but the mass is still the same. So, if they both will pull no the table, so 2 seconds na lang, almost na half nga naman, it's because na double ang imuhang force but the mass is constant. Now, we also have another here, no, mass gibira sa karon ni student A, and this mass is moving with an acceleration, let's say a sub 1. Gitabangan siya sa iyahang classmate, which is this one, duha na sila kabuok, and that particular the same mass is now moving with an a2, but the a2, that acceleration is just equal to your a1 times 2. Ngano man, it's because duha naman ang nagtabang og bira. Okay? Same here with the last one. Same ang mass, pero tulo na sila. So, that mass is now moving A3. Pero that A3 is basically your A1 times 3. Kaya tulo naman sila nagtabang bali. No? So, in this case, we say that if the mass is constant, as the applied force increases, the acceleration also increases. Kung wala na change ang mass nimo, pero na-change ang imong applied force, so the applied force is directly proportional to your acceleration. So, the same mass, wala gidugangan, wala gikuhaan, but you increase the applied force. Kung imong gituklod, mas gi-increase nimo ang force para matuklod ang usa ka butang. If you pulled, if you gibira nimo ang isa ka butang, gi-increasean nimo or nagpatabang ka from your classmates. So, ni-increase ang imuhang applied force. So, your acceleration will also increase, granting that your mass is constant. Okay? Mass is constant, ha? Please do not forget about that. Okay, next. How about in this case, baliktaron nato. What if the same mga tong applied force? Di ba mo na tong example kagaina nga last time nga mansari tapos nagkuha siya og gift nya kinahanglan niya ma sa ba matagnaan ng acceleration, no, para ma-free ang yang gift. So granting that the applied force is the same, is constant, ang nagkalahi-lahi lang karon is the mass. So when we try to observe, no, the relationship between the mass and the kuan in the acceleration is inversely proportional. Buot pasabot, if gamay ang mass, mas paspas siya mulihok or mas paspas iyang mas dako yung acceleration. But if dako ang mass, gamay ra pud yung acceleration. Kay the same raman ang imuhang applied force. So we say that acceleration is inversely proportional to the mass. Kung bugat, kung mas dako ang usa ka butang, but you applied with the same force, muhinay gid siya yung pagdagan. Compared sa katong kuan nimo, mass nga medyo gamay, nya same pagyud og force. So, mas paspas ang acceleration. So, we have inversely proportional. And if we try to combine the two, we have acceleration is directly proportional to force and acceleration is inversely proportional to mass. So, we combine them and we will now have this expression, and we can cross multiply that and we have F, then we have there MA, and this is now our mathematical description of a law of acceleration. So we have force is equal to the product of the mass and the acceleration. Yon. So para matagaan nato sa og importance, no, ang idea, we will have an example. A 30 kilogram box is moving in the right side of your screen with an acceleration of 0.5 meters per second squared. So the question now here is, what is the applied force? So we take note of all of the kuan muna, the given. Mass is equal to 30 kilograms. Acceleration is equal to 0.5 meters per second squared. And then the force is equal to ma, which is our formula. So basically, we substitute everything. So we have 30 kilograms multiplied by your 0.5 meters per second squared, and you will end up with 30 times 0.5, you have 15, and then kilogram times meter per second squared is you have newtons. Now take note, the formula F is equal to ma is the same with the formula of the weight. Kasi yung weight is equal to mass times the acceleration due to gravity. That simply means the weight is also a force. 'Di ba? Okay, that is the resultant of the interaction of the acceleration due to gravity or the gravitational force and the mass itself. Okay? Sige. Now, in this case, we also have another example. Ma-play ba nato na siya? Ayun. Ma-play siya, no? In this example naman, ano siya? You apply the same force, pero different ang mass. 'Di ba? Mao na effect sa babae. But if you apply the same force, pero to a massive person, mura na yung effect. Mura rag wala. 'Di ba? Or nilihok siya, pero dili siya ingon nga lihok yun kaya sa nga tanan. Okay? So, that's the effect of, or that's the concept behind law of acceleration. So again, wala siya naglihok, law of inertia. If you push, if you change the current status of that particular object, kung wala siya naglihok, imong gituklod, gibira, gisipa, gilaparo, gisumbag, whatever, there is a change in the acceleration, or there is a change in velocity which caused the acceleration. Under na po na siya sa law of acceleration. But if that object will continue move, will continue to move with constant acceleration or constant velocity pala, sorry. With constant velocity, mubalik na po siya sa iyahang pagka first law. Okay. And the third one is very simple, the law of interaction. So the law of interaction simply states that if you uh, push something that is your ano, or if you pull something that is your action, there is an opposite but equal or opposite reaction in that case. So for example, this is Miss Barbara and iyahang kuan Mr. Barbaro. Nagtag of war sila. So gibira ni Miss Barbara si Barbaro, gibira niya with a force of 20 newtons. So the third law states that there is an opposite and equal reaction, which is in this case 20 newton pod nga force padulong pod kang Mr. Barbaro. So that is your action and that is your reaction, the blue one. So ibig sabihin equal talaga siya and opposite. But last time I asked you the question, why is it that we cannot cancel them out? Kaya 'di ba kung 20 newton ang imuhang action, positive for example lang, tapos ang imong reaction kay opposite, di negative 20. So dapat ma-zero. But in that case, that's not what's happening. Kay kuan man siya, they are on different bodies man. We cannot cancel them out kasi they are on different bodies. Wala sila sa isa lang ka body. Okay ba? Nasabtan ba to? Okay. Now, um another example also, the action there is the ball. Niadto siya, the force of the ball padulong sa imuhang ground or sa imuhang tawag ani floor, and then the reaction is the force applied by the floor on the ball para mo kuan po siya bounce back. Okay, so again, force of the ball paubos, that's the action. Force of the kanang salog padulong sa ball, that's the reaction itself. So action and then reaction upwards. Another example also is when you do biking, when you also walk, when you also run, you apply a backward action on the ground, and in opposite, the reaction of the ground is gina-move ka forward sa ground also. So, mo na siya ang imuhang action-reaction relationship. Also, if ever nga example, mag-swimming ka, so pag ana nimo ang imuhang kamot, you will apply force on the water pero pa backwards. So, mo na siya action. Ang reaction adto is the water will apply the same force on you para move forward pug ka. So, mo na siya ang action-reaction relationship under the third law of motion. Okay? So, very simple lang ato ang mga basic. Again ha, these are just the basic nga mga tawagan ni concepts that you learned in grade 8, no? Grade 8 ra na siya tanan ha. So, ayaw mo kalimutan na. Okay? Now, in this case, na-discuss po ta last time og I will make a separate video related to the sample problems on the first and the second law. So, ang first and second law actually is the same lang siya. The only difference is when you do the summation. 'Di ba kung first law, summation of all the forces in x or y axis is equal to 0. Kasi nga, first law siya. Pero kung mo second law na, igura ni mo alisdan og summation of all the forces in x or y is equal to MA. No? Kay nag-move naman siya. Okay? So in this case, nakita nimo dinhi sa ato ang kuan, nakita nimo sa ato ang screen. This is an example of how you make an FBD. Okay? Again, I will make a separate video related to that. So please do not forget that FBD should be based on the orientation of the body. So kung ang imong body is nakatakilid, nakaingana, takilid pud imong FBD. Pero the weight is always downwards. Ha? Ana gyud ang inyong numduman. You always make the FBD based on the orientation of your body. And then do not forget that if the body is in contact with a surface, there is always a normal force. And then another thing, if the body is connected to a string, a rope, or a chain or yarn, that particular rope, chain, or yarn or rope will experience a tensional force. Okay, tensional force na siya. Okay, another thing that is very, very important is our discussion on the friction. Di ba friction is a force that opposes the movement? So example, if the object, in this case, here, if the object is constantly moving, wala din siya nag-move, kani, no friction at all. Kaya nga wala may movement. Ano sa may yung i-oppose? 'Di ba? Now, in this case, weak applied force box remains at rest. Naan siya is static friction. Please take note that static friction is related to a body that is not moving yet. Pero, kato siya nga friction is, that friction causes the body nga dili siya move. Kaya nga naman, imo man gi-apply, unya iha man gi-oppose. So, munang wala siya nilihok. Naay friction. That's static friction. Pero, if ang imuhang gi-apply nga force, mo equal na gali siya sa static friction, so stronger apply force box just about to slide. But pasabot, kanang equal na gyud, hapit na gyud siya, padulong na gyud siya mo move. But, if the applied force is very, very strong compared to your frictional force, kana nga time, move na siya. But your frictional force is now opposite to the movement. And in that case, naa na kay kinetic friction. No? So, you can solve the kinetic friction by multiplying the mu k, which is basically the coefficient of kinetic friction multiplied by the normal force. You can also solve the static friction here by multiplying the coefficient of static friction times the normal force. So kani siya kanang coefficient of static and coefficient of kinetic friction magdepende na siya sa material. Okay? So lahi-lahi nga material, lahi-lahi pod og kanang coefficient values. So akong otrohon, kung wala naglihok, walay applied force, wala pa friction. Kaya wala man siya i-oppose. Pero if there is a weak applied force, na friction. Ang problema lang, ang imong applied force, dili pa enough. Di pa mo sobra sa imuhang friction para mo move ang isa ka butang. And in that case, that particular object has now static friction. And if the moment nga hapit na duol, like almost the same na sila, dili pa siya mo move pero ready na siya mo move. And the moment nga mas mulabaw na or mo increase na kaayo ang applied force compared to your frictional force, then nanay movement nga mahitabo. And in that case, we call this now kinetic friction instead of static friction. Okay? So again, please do not forget to remember and to check all of these basic concepts about the laws of motion. And I will make a separate video on the sample problems answering one siguro, one problem answering the first law of motion, one or two, depende na siya. And one example for the second law of motion. Okay, so that would be all, and thank you so much. Please do not forget to check the other videos, ha. Bye everyone. Be safe.